as we start the panel discussion, I would like to introduce Dr. Leslie J. Cohen, who is the Senior Vice President of New Business Development and Strategic Technology at Hitco. Thank you very much.
Thank you. Thank you. And like my fellow speaker from Northrop Grumman, I'm a Yankee fan. It's supposed to get a laugh from the Cleveland people. So today, we have the honor of having three outstanding panelists to talk about the subject of data analytics for manufacturing. And so they asked me before this thing started a couple of days ago, you know, what leading question did I have on my mind, just in case you didn't have any questions to offer them. So I'm going to offer you one to start thinking about. Because when this thing was started by DARPA some 30 years ago, the holy grail was zeros and ones in analytics, and we don't have to do any testing of any real consequences. The holy grail, do it analytically. Think about that when these people are speaking as to challenging them where we are in the quest for that holy grail. I'm going to ask George Barnych, who's the Director of Research and Development of Digital Manufacturing Design, to be our first stand up and say a few words.
Stand up or can I
sit down, or however you want to do it. And I'll cut you off after about 10 minutes.
Okay, that sounds good.
And if you have some slides, they'll show them for you. So you just...
No slides.
Right. Go ahead.
Okay. For those of you that aren't familiar with what DMDII is, the Digital Manufacturing Design Innovation Institute, it's really, in a nutshell, it's a partnership. And the partnership between the federal government and local governments, industry, and academia really kind of coming together and trying to address problems in manufacturing that are bigger than just one company. Because, you know, individual OEMs have the kind of power to put research and development dollars into the things that they're particularly interested in that's usually competitive in nature. So the idea behind the Institute is really to kind of pool a lot of resources together, to get a lot of experts together from across the country and really try to tackle the problems that are just bigger than one company. And it's quite amazing to see companies like Caterpillar and John Deere and GE and Rolls-Royce, Boeing, Lockheed Martin, companies that generally compete a lot, and they also collaborate. But to get them to work in the Institute together is quite interesting, and they tackle usually a lot of the pre-competitive type of research. And so it's kind of run like a business. The government isn't dictating like how the money is spent. It's driven by the industry, really. And it's kind of a very collaborative type of approach to finding out where we should put the research in. And we do project calls every 6 months. It's kind of a white paper process. You put in your ideas. We have subject areas that are solution agnostic. We don't try to prescribe the solution. And we get a lot of innovative ideas from, you know, universities coming in with their ideas, small companies that have innovative ideas that are looking for big OEMs to support them. So that's essentially what the Institute does. It really kind of facilitates funding of research. That's one primary function. And another function is a workforce development component. Right now we're doing a major taxonomy for digital manufacturing to kind of try to identify what those skill sets are and so forth to try to propagate the workforce development efforts that the government's supporting and local, like state governments that are putting money into that effort. And the other is really trying to help the supply chain. A lot of the big OEMs are not coming to DMDII because they want the research dollars. The big OEMs are coming in because they need to see their supply chain get lifted in their digital capabilities. And it's really all for the connectivity and the visibility into the supply chain, which can get a little dicey, especially if you have know-how and things that you like to protect. So one of the key things the Institute wants to solve through this collaboration is how do you get access to the production lines and what's happening in a real-time dashboard type sense where you can be a major OEM and kind of control your supply chain without really violating the integrity and the know-how and the competitive capability of the tier 1, tier 2, tier 3 suppliers. It's not an easy trick because you have opposing desires there. So we're hoping that through the efforts that we do at the Institute that we'll be able to achieve something in that area. I have plenty more I can talk about, but I'll...
Well, can you give them an example of some of the analytical programs that you're using to drive new solutions in manufacturing?
We're kind of a facilitator. I mean, we have companies like 4Chem and so forth that have their solutions inside the Institute running and functioning. We have a 38,000 square foot manufacturing lab, and we've got Mori equipment, Haas equipment, and right now it's in sort of a pseudo-static state because we're getting the infrastructure put in, and we're really going to be a place where people who have analytical software can put them into the Institute and exercise them against the machines. Because this year is going to be kind of a very pivotal year for the Institute. This whole year, up until this point, has been a lot of lawyers agreeing on an agreement and getting things finalized, getting that vehicle where people can collaborate. But this year, we're going to actually be standing up a fully functional example of a digital thread at the Institute, at the facility. And the idea here is to be able to allow companies with analytical software, all the way from like the CAD programs, your PTC, Siemens tools, through CAM software, through inspection software, all of the full basic PLM. They're all going to be nested in this facility. And it's all switchable and configurable so you can plug people's products in and out of different configurations. So ultimately, if we reach our goal at the end of this year, you'll actually be able to configure that entire sort of a representative digital thread or tapestry, if you will, and you'll be able to plug different OEM software packages in and out of it in different combinations, essentially kind of replicating different IT structures. So if you do that, you really have a very cool hardware-in-a-loop system, if you will, to test a lot of these capabilities and so forth. So we're not inventing the analytical software. We're basically funding the research and getting them to debug it, if you will.
Thank you. To his left is a good friend of mine, Roland Dutton, who's the Chief of Manufacturing and Industrial Technology Divisions of Materials and Manufacturing Directorate, better known as Mantech. And the Air Force Manufacturing Technology Program resides in his hands.
All right, thank you.
And he's an old DARPA guy on the AIM program and has a long history of computational mechanics. Rolly?
All right, well thank you. First thing I want to point out is, remember our previous speaker? You know, that's an exquisite piece of machinery. What did he say? Build, test, build, test. All right.
Excuse me, can everybody hear?
My mic's not on. Is it on?
Thank you.
All right. As I said from before, our previous speaker, exquisite piece of machinery, build, test, build, test. I'm sure they're simulating a lot, but at the end of the day, the test is what makes the proof that it works. All right, the Air Force is in the process of recapitalizing, you know, new F-35, a new bomber, new tanker, and so forth. All right, so we're starting to change. At the same time, we're flying B-52s that'll end up flying 90 years. So exquisite breadth of systems that we have to maintain and operate. Now, the systems that we're building now, the capabilities are becoming extremely good. And what we find is the better they are, the more impact manufacturing variability has on those capabilities. And it certainly has a big impact on delivery schedule and cost. All right, our challenge has been that we're not able to estimate the impact of manufacturing variability on systems performance. Simple as that. We have to try it, and then we find out we didn't make it. Now you have to go back and have non-recurring engineering costs to fix it. All right, that's very expensive. It also takes a lot of time, and it basically destroys our trust in the whole supply chain that says, can we really do this? Can we make a robust system that can operate in the 21st century that's not just a one-off tool? All right, so what we need, the data analytics, is to incorporate all the information across the supply chain to assess the impact on the capabilities of the system and calculate a risk. Now, that doesn't mean we're going to minimize that risk, but we want to know what risk we're taking. We want to be able to get a system where we can make it more or less right the first time delivers the capabilities, and we know we can maintain it, we know we can sustain it, and we know, based on every Air Force system we have, that the mission profile of that platform will not be what it was designed for. All right, so we've got to be able to come back and make those decisions about if we're going to operate in a new regime, can we do it safely? Are we putting pilots at risk? That means we have to have all that information readily at hand to make almost redesigned decisions. That's a challenge. All right, so what we're going to say is we don't really need your data, but we need to have access to your data. We're going to tell the OEMs we don't really need your models, but we have to have access to your models. All right, we haven't worked out the business rules of engagement to have that paradigm happen. We're doing it in real time. At the Air Force, we have a couple programs right now called Digital Thread for Material Review Board. All right, we picked that. A material review board, for those that don't know, is if you have a part that doesn't meet specs, someone has to make a decision. Do I repair it, do I scrap it, or do I go with it as perhaps with a reduced life? Someone makes an engineering judgment on that part. All right, so in a microcosm, that's everything I just talked about. We're making a decision about a part. So what we're doing is those small use cases to begin to understand what's the impact of having that information to support an engineering decision. And we're finding it's pretty darn big. All right, so we won't come up with a big system that says, here's the digital thread for the Air Force. We're going to build this a little at a time. We're going to build the use cases, and we're going to build the tool sets and tailor them. Will we ever get away with no testing? Absolutely not. But what we want to do is be able to explore digitally the impact of manufacturing variability and then confirm it physically and then make the part right the first time.
Noble goal. To his left is Ray Johnson, who just recently retired as the Chief Technology Officer of the Lockheed Martin Corporation and is now an active individual in the community of judgment. And he's certainly got a lot of it, having had that position for 10 years.
Leslie, thank you. Mike.
I think you might pick it up a little bit.
Hello. Hello, hello.
There we go.
Wow.
Thank you.
Okay. How about now? Wow, okay, we'll hold it. First of all, thanks for inviting me to be on the panel. It's great to be able to talk with a lot of former colleagues who are here and meet some new friends. I am very bullish on data analytics. I have been for a long time. I think it's very important. What I want to do in my brief comments now, kind of mention some of the areas that I think data analytics will play a major role. Analytics in manufacturing have been around for a long time. But analytics as a tool for quality, performance, and sustainability is quite new. And the ability to embed data analytics as part of the manufacturing process is also new. And I want to say why I think this is so important. It's really important to the aerospace and defense industry. If you look at the macro level, the DoD budget is under tremendous pressure. As that pressure continues to grow, which, by the way, it will, the world's a very dangerous place, but we have retiring baby boomers, interest rates that are getting off zero, increasing healthcare costs, so the macro pressure on the defense budget is going to continue. So given that, the number of New START programs is going down. And as the number of New START programs goes down, the ability to implement innovation and changes in the design process go down. So many of the large aerospace and defense companies today, call them the primes, many of the primes now become manufacturing engines rather than design and manufacturing engines because the number of New START programs has gone down. So therefore, if you want to implement innovation and increase profitability and actually keep programs alive because of the pressure on the budget, you need to do that in the production environment. So that's why it's so important. Both George and Raleigh mentioned the digital tapestry and the importance to link down to the supply chain. And we implemented within Lockheed Martin the digital tapestry maybe 4 or 5 years ago as a concept. And simply put, as you digitize the environment from concept to design to engineering to manufacturing and to sustainability, that's a thread. And then if you think about that thread becoming a tapestry, you take that down into the supply chain. The visibility in the supply chain at the first tier is okay, at the second tier is limited, at the third and fourth tier is almost zero. And so how can you use the digital tapestry to influence your awareness and to drive that data analytics into the supply chain so that it becomes an integrated part of the process. We've heard a lot about IoT, Internet of Things, Industrial Internet, et cetera. In many ways, data analytics is an enabler to a smart IoT or a smart industrial internet. Advanced manufacturing. There are a number of sessions here on advanced manufacturing. It's very important. It also enables new capabilities. If you think about as the advanced manufacturing, additive manufacturing now can embed electronics into the process of manufacturing, now you can think about the sensors and the electronics being embedded into the materials as they're developed and be a component of the overall design. And to Leslie's question about test, it certainly will not eliminate all test, but it can provide the kind of feedback in the materials, in the components that would allow you to at least do testing in a smarter way. Embedded sustainability, I think we've talked a lot about predictive analytics and the importance there, and certainly that the embedded electronics and the associated data analytics will support that. The ability to measure compliance and traceability to the machine level. As Leslie mentioned, I was for a little over 9 years the Senior Vice President and Chief Technology Officer at Lockheed Martin. I today am on the board of, as the sign says, on the board of United Sciences. United Sciences is an example company of how you begin to trace things during the manufacturing process so that you can follow that design and the quality throughout. And the last comment, I guess, is on quality management. And you can actually, through data analytics, you can actually link the ability to trace to quality, to daily manufacturing, to individuals, to processes.
Something's going to launch.
So again, thanks for inviting me to be on the panel, and look forward to the additional discussions if you can hear us.
They're making milkshakes back there.
Something's going to launch.
We'll turn it over to the audience to stimulate a Q&A. I don't know if they have cards or... Do we have a card there? We have a question? He wants me to include the Dodgers. How do you think that data analytics will be used in the following areas to reduce cost and improve performance? Initial design, manufacturing. Outstanding question. You took it from me. So in terms of a business case, tell me the business case.
Let me take a first shot at that.
Go ahead.
We're living it with the F-35. Again, you're making an exquisite system, and then when you go out and start flying it, you find things happen.
Here, Mike, again.
Okay. Mike, is it live? Good? Okay. All right, so what happens is that we learn during the testing, and there are surprises that in hindsight look back and say, well, maybe we were in a new area, so that surprise is just part of pushing the envelope. And then sometimes it's, we should have known. All right, so how do you discern that? How do you roll up all that complexity to make the decision? That non-recurring engineering cost is one of the main reasons for the cost growth of the F-35. All right, so what we need to do is have that first estimate of, again, the impact of manufacturing variability on the design, and how much room do we have to play to build in that robustness, and the robustness is built around the supply chain, not just a specific component, but the supply chain.
So if you're writing a proposal for a new airplane, and you needed to tell the government why you were going to be $3 billion lower in your ability to bring this forward from engineering development to production, how much would you assign to the process of data analytics and simulation and manufacturing to accomplish that? What's it worth?
Okay, wow, that's a hard question. Well,
You didn't have that
first of all, I'll never get to make that decision. But
you may score it, though.
I'll be scoring it. I think what we would do is we would say data analytics is a tool. All right, so it's about how you use the tool. It's not the tool in of itself. If you say, I have the software that does that, well, so what? What we want to do is say, all right, how are you incorporating that information back to close the loop in the design process? And what we would say, let me put it this way. Personally, what I would say is I want you to go back and look at some of your train wrecks. I want you to demonstrate that using this approach would have mitigated that. And you only have to talk to the government, so there's no sense that you're exposing anything, but show us that if you'd done it this new way, that you would have missed that. Or you would have caught that. And then I think, all right, you have some credibility.
Anybody else want to take a shot at it?
I guess the only comment I would make is that it's an integrated process. I don't think it's an either or. It certainly can be, it has to be integrated during the design process to be usable during the manufacturing process. And so I think it's, it has to be considered throughout the life cycle. And of course, as I talked about, through sustainment as well.
Yeah, I can add one piece. I can a little bit drifting off, but there's actually a vision to create some artificial intelligence software that would actually reside as a plugin into the CAD programs. And the purpose of it, you use the data analytics to start developing the algorithms. And then what that does is it provides you real-time feedback while you're designing with respect to cost and lead time. I know it's kind of trivial from that standpoint, but I have a feeling that if it progresses in that direction, people are going to start innovating new ways to use that, and it's going to become more and more and more intelligent. So I think initially, if you hit the cost and the producibility stuff to help guide the designers as they're doing it in real time, it'll start evolving into getting more sophisticated.
So in my structures background mind, I know you will have arrived when there's a seat at the table for the guy with the title called Data Analytics, and he's at the IPTN. He's at the table, one of the 8 or 9 at the table, along with the supply chain manager. And then you got to vote. Second question, what types of analytics do you believe can take the industry from descriptive, backward-looking, to predictive, forward-looking? That's a pretty tough question.
I mean, what kind of data? I think this has been done for a while. Condition monitoring's been done for a while, and the predictive maintenance has been around. So I'm not exactly sure what to say beyond that.
I'm going to say, most of what we see people coming in with are Bayesian techniques. That appears to be the tool of choice. They take information and turn it back around and make a decision.
I mean, I think it's the lack of the information that's
right.
really the problem, not the processing.
It's more or the noise in the information. It's very difficult to get the signal out that says this is what it's telling you. All right,
I think there's an iterative process between what is embedded to collect data and what the algorithms can exploit. And so I think over time, as algorithms are developed, maybe to your point about the AI system, as algorithms are developed that indicate, wow, if I only had those data, then I could do the following things, and that will feed back into what gets embedded. And I think that companies like GE, just to name one, with the industrial internet and with the increased use of embedded sensors, will feed those algorithms that allow you to do more than a broader range of predictive analytics, more than just this part's getting ready to fail.
Let me make one closing comment on that. We all live by this now. We couldn't do business without it. There's an app for that. All right, so same thing. These apps are going to evolve, and they're going to evolve as local solutions. So there will not be a grand analytic tool that solves everything. There'll be a lot of local solutions. It's having that agility, just like the apps, but it's the integration of the information that's the hard part. That's what's going to give chief engineers fits, because they're the ones that are going to have to pull all this together and make decisions.
So this is a very good question that I have here. It's really where my head is on this whole subject. What are the new metrics or measures? When you're writing that proposal and you're writing that opening letter to the procurement officer, it says the discriminators of our offer are based upon the following, and here's how we've been measuring them. How do you measure your success?
Reduction in non-recurring engineering cost.
Aha. There you go. See?
Okay.
So that means you're going to impact a big chunk of the dough.
Big chunk of it. Right the first time. Demonstrate that you have processes that will deliver that.
Anybody else?
Well, the logistics and sustainment of a weapon system cost a bigger number than the development of the weapon system in production. And so therefore, any impact that you can have on the maintenance sustainability is going to drive things. I think maybe a bigger question is, in your proposal to the acquisition community, are you going to be given credit for the gains that can be, or the cost effectiveness that can be achieved during the sustainment, or is the acquisition only not considering life cycle costs, and so therefore it's only the design and production costs versus the sustainment cost? So I think that's a bigger question, because you can certainly, I think, demonstrate value on the sustainment side.
You brought up a good point on the supply chain. The supply chain for just about everybody now is very brittle. You've got a few companies that everyone tends to work with, and they're always kind of on the bubble. And so how one would function in a supply chain environment that is that fragile is key to the success of sustainment. So a lot of it's going to be, how can I get how can I have a distributed supply chain? That if these suppliers disappear, I'll still be able to make parts for these systems.
Yeah,
So the promise is we're going to package up all this zeros and ones and drive the cost down. And
Yeah, but the metric is really after the fact, unfortunately. What everybody's
you
looking
don't sound
for
like
is
you're a fan.
no, I am, but I'm a suspicious fan because data is a tricky thing.
I would prefer you use the word skeptical rather than suspicious.
Better vocabulary. How does a company become a member of DMDII?
yeah.
And what are the privileges and obligations? You got your 5 minutes.
It's wide open. We accept anybody really that's out in industry that wants to become a member. You just contact, go onto the website, contact a gentleman named Jacob Goodwin, and discuss what you're interested in terms of a level. Tier 1 members get a benefit of using intellectual property that's developed with government co-funding to implement it in their operations for free at no cost. Tier 2 members get to experiment with it and so forth, but they can't deploy it in their operations. And the Institute doesn't own any of the IP. The IPs are owned by the individual companies. So really the benefits to membership is the ability to implement things within your operations if you like technologies that come out of it, and really the collaborative, the information that's going to come out in terms of frameworks and use cases and things that come out of the Institute. So it's very easy to join.
What are the benefits to small and medium manufacturers to making data available?
Okay, I want to comment on that. What you're seeing as a paradigm is you want to be paid for not just what you deliver, but what you know about how it was made. So you're being paid for how smart you are as well as what you're able to do. We haven't worked out those rules of engagement yet. All right, so what we're saying is there's something when the part comes, there's a data package that comes with it that is of value for us when 30 years from now, when we have to do a service life extension on that platform, we're going to open that up and say, this is exactly what we need to make this decision. All right, so we have to take that longer view of the data, and we have to say, what do we ask the supplier to include now that we've traditionally never taken advantage of?
So lay on top of that the cybersecurity issue.
I'm going to speak personally. I think we can hyperventilate about cybersecurity and get too worried about it. Right now we're able to work with credit cards and ATMs and so forth. I think it'll work out. It'll be okay. And I think you can worry too much about cybersecurity and miss all the normal stuff that happens that drives most of the expensive failures.
I think in some ways, if you were a small or medium business, it's kind of being part of the game, and being part of this environment. As you say, the supply chain is very fragile. You're 1 or 2 deep in critical areas. And in terms of the question about cybersecurity, I think it's more than that. I think the digital environment allows you to gain insight into counterfeit parts, conflict minerals, cyber issues. We conducted a voluntary survey of the suppliers to see how many of them were essentially compliant with cybersecurity rules voluntarily. And in the voluntary process, about 50% of them failed. And this was not a deep dive. This was just answering some straightforward questions and then doing the assessment. And so I think cybersecurity, I don't know whether you wring your hands over it or not, but I think it's a big deal. And it'll become a very big deal if we find that it's not, let's call it supplier security. If we find that it's a pathway toward bad things happening, especially as we become more digital and everything is software, I think that'll be that could cause the industry a lot of grief, because anytime you deal with an industry whose foundation is in security and defense of nations, and then you have issues associated with cybersecurity, it's going to be a problem.
So we've got time for 2 more questions, and I have them both here. Thank you for, maybe I got a third one? That's it? Oh, go, okay, so they're excellent questions. Anybody who wants to take this one? Any successful examples of digital thread implementation that you can share?
I think that's a Lockheed answer, right?
Oh, yeah, I mean, I'm not going to be able to go into details, but certainly there is the digital thread is a component of manufacturing within a number of programs in the corporation today. And the digital tapestry is under development, as I said. So I think, this is not a fantasy land. This is real. And the ability, the work that's being done in advanced manufacturing and embedded electronics, the work that's being done in all of the areas that I commented on during the introduction, these are real things. These are real things that are a subject of this conference. And so it is happening, and there are real examples. And I think the opportunities to influence, to make manufacturing take a major role in affordability in the manufacturing process, and then certainly, as I mentioned, in the logistics and sustainment, which it can be more than the manufacturing, design and manufacturing, huge opportunities. So I would use the opportunities of this conference to learn more about it and embrace it, because it is absolutely going to happen.
So I'm going to paraphrase the question I have, because it's my privilege to be able to ask my own question. In the context of certification, you have an idea of how much faster it's going to go? And forget about less expensive. How much faster will it go?
Yeah, I don't
Look at
think-
that Webb telescope,
Right,
for example.
right.
I don't think, I mean, I'm not sure what your question is, but I think it's not faster. I think it's slower. And so the question is going to be, so certification and qualification in advanced manufacturing, in the digital environment, in embedding new things to give you that feedback that are not just based on statistics, that are actually based on embedded components. That certification and qualification process is complicated, and I think what we need to do is see, and I would put an appeal out to the people in this conference to create pilots to go through that certification and qualification process, because after it's done and you go through the pain of doing that, then you can take advantage of, I think, what your question implied, and that is doing it faster. But it's going to take some time to get the pilots through and to get the process to adapt to new materials, new processes, new integrated components, and the digital feedback that they provide.
Painful in the beginning, but the benefits are
I
out
believe
there.
so.
Roland?
I give a slightly different take on that. What we would like, first of all, qualification is going to change because we're going to be testing different parts, and those parts are going to be designed to test the limits of the manufacturing process. We're going to ask you to make -3 sigma parts and then load them up and see how they fail and find what those defects look like and what the effect is on the structure. All right, so rather than building a lot of nominal stuff and testing a lot of nominal stuff, we're going to want you to go to the edges of the process. That's very valuable information. And what that does is help us tailor the certification so we know exactly what we're getting. And again, that builds a big bank account when we do a service life extension 30 years from now.
Thank you. I want to thank everybody here for attending. I want to thank you for your cogent questions. And the speakers will remain up here. They have some things they want to.
Okay.
There you go.
Yeah, have a seat, Les.
Have a seat. There you go. Have a seat.
On behalf of SME, I'd like to thank Les, George, Roland, and Ray. Will you join me and give them a round of applause?